kiddos, Miss Wallace here. I want to talk to you a little bit about solutes and solvents. So we've been talking about mixtures and solutions. We know that solutions are a special type of mixture. We see that here in this sentence. But we want to break those solutions down into the two components. So we have solutes, and what we need to do on this notes page is we're going to take this line out. Solutes are dissolved. And I'm going to tap this in all caps because that's important to know. The solutes are what are dissolved in the solvent. So some examples of solutes, some examples we've used in class: Kool-Aid powder. You capitalize that since that's a name. Or you could say powder drink mix, right? Sugar, that gets dissolved in water. Salt would also be dissolved in water. You've got an example down here at the bottom of the screen, Nesquik powder, right? That could also be a solute. Now, here in this blank, we need to talk about what is the universal solvent, okay? So I'm going to tell you a funny little story in a second to help you distinguish between a solute and a solvent. So H2O, or water, is the universal solvent, meaning that most things will be dissolved in water. You put your Kool-Aid in water, you put sugar in water. The ocean, we have salt water, so the salt is dissolved there. I'm just going to drop that little 2 down as a subscript. So H2O, we know that's the molecular formula of water. So when solutes are dissolved in a solvent, right, the solute gets dissolved in the solvent, that's when they're going to form a solution. And so that's what we have been studying in this unit. So solutions, we know Kool-Aid, once you have dissolved the drink powder in there, that is a solution. You've got ocean water, not from Sonic, but from the ocean. However, an ocean water from Sonic would also be a solution. Soda, right, because you have sugar dissolved in that water, and then you carbonate it, and that gives you your soda drink, whether it's Sprite, Dr. Pepper, anything like that. I want you to think about lemonade, right? Lemonade, we put sugar in there to make it sweet, and so that would be a solution. So the solute is always going to go into the solvent. So let me tell you a funny little story, and this is to help you remember the difference between solutes and solvents. So once upon a time, there was a thief, and this thief loved to take precious jewels and gold and all the pretty jewelry that he could find. So he breaks into a jewelry store one day, and he has just gotten the biggest diamonds he could find, all the gemstones, all the gold, and he's put it in a bag. And so we're going to call that his loot, right? So like the loot that he is stealing. Well, all of a sudden he heard sirens going off, and he heard, or he saw cop cars pulling up to the store. And so the thief thought, oh my goodness, I'm going to get caught. So he took his bag of loot and he hid it in the air vent in the store. So the loot went into the vent. And when the cops came into the building, the thief acted like he was a worker there. And so they never knew that he had stolen the goods. So I say that because in our story, we'll say the thief put the loot, this is how you would spell that. Then in parentheses, I'm going to put this loot, which we're talking about solute, into the vent, right? And so we're talking about solvent here. So let me go back. I'm going to change this to solute, okay? So the thief put the loot into the vent or the solvent, meaning that the solute goes into the solvent. Okay, that's just a funny little story just to kind of help you remember that. It's not necessarily a concept that you're going to be tested on, but it does help you understand solutions a little bit better. So I hope this helps you out. If you have any questions about it, please make sure that you let me know. Okay, have a great day.